So if we're going east and we turn left, we'll be going south. If I get this right, this is going to be amazing. Hey everybody, welcome back. I hope you're doing okay. This will be the fourth video in my series on getting ready to have a go at Advent of Code 2025 in Rust. And I wanted to start this one by saying a huge thank you to everybody who sat through my last video. You're all amazing and you deserve an award. Thank you very, very much for watching. And I want to give a particular shout out to those people who, having watched the video, then took the time to leave a comment. So I'm not going to try and pronounce anybody's names, but thank you very, very much for your kind words. Thank you to this person who pointed out that I need a part 1 and a part 2. Yes, you're absolutely right. I created a run function last time with just some code in there that would make the tests pass. But of course, Advent of Code, if you're not familiar with it, we're going to be having a look at 2016, by the way, the puzzles in Advent of Code 2016. So each day the puzzle comes in 2 parts. So you get the backstory in the first couple of paragraphs and then some specific information about the puzzle for that particular day. And sometimes a link off to, Wikipedia page. So taxi cab geometry, we'll have a look at that a bit later. And then some sample inputs and expected outputs. So these are the things that I've, these inputs and outputs are what I've used for my tests, for my assertions. So expected output of 5 for the input of R2, L3, etc., etc. So that's generally how I set things up, and I did all of that in my last video. But of course, you need to solve both parts of the puzzle. So my run function will, when I write the code, will solve part 1. When I put my answer in, when I get it correct, it will reveal part 2 of the puzzle, which kind of builds on part 1. So yes, absolutely right. I guess in a minute, we'll rename run to part 1, and then we'll add part 2 function to solve part 2 of the puzzle. So yes, thank you for taking the time to make that suggestion. That's exactly what I'm going to do. Thank you. And then a particular thank you to this person who began their comment with "so," a word that I'm trying to say fewer times in the videos. I probably won't do very well, but thank you so much for taking the time to so eloquently explain what's going on when you use the include string macro. I'd said in my previous video that when I had a go at doing Advent of Code 2015 in Rust a couple of years ago, I had used the read to string function from the FS module. We can have a look at that. Read to string. Here we go. So I wasn't doing exactly this. I wasn't using the question mark operator at the time. I was just like calling an expect on read to string. So read to string gives you a result, which is an enum, and it has 2 variants. So that's how I was doing it. But yeah, this person pointed out that when you use include string, it's as if this is exactly what's going on. It's exactly as if you typed all of the contents of the puzzle input into your program as a string literal. And as a consequence of that, the input.txt, the contents of it at the time of compilation gets written into the binary. And so subsequently, if the contents of that file changes on disk, you're going to need to recompile the binary to see any change in the output of your program. So I did say, I think when I replied a couple of days ago. I was saying that I would probably switch back to using read to string, but I actually think that this is probably okay for Advent of Code. I don't think I've come across a puzzle where the puzzle input has changed for part two. So, and I think, I'm going to be compiling each time I run my program anyway. So I'm kind of thinking that I'll probably stick with this approach for now. And yeah, take this on into my actual sort of Advent of Code 2025 attempt. So probably leave it set up like this. But thank you so much for taking the time to explain the difference between the read to string function from the FS module and the include string macro. Right, so as I mentioned, we're going to be having a look at the day one. We're going to be having a look at the 2016 puzzles. I don't know how far I'm going to get through them. We have about 2 weeks to go before Advent of Code begins. But yeah, I've got to sort of get back into it. So what I realized, first things to do, I think we need to, as mentioned in the comments, we'll replace a run with part one. So that's the first thing we'll do today. So we want to replace that. Yes. So that's that bit done. And I think probably we'll see how we get on today, but or tonight. It's getting late. We'll see how we get on, but I might just do part one, see how it goes. I have no idea how long it's going to take me, so we'll see. The next thing I think we need to do before I forget is just add a trim on the end of here to remove any carriage return new lines at the end of the file. So yeah, I think that should sort that out so we won't hit that problem down the road. Okay, so now what we can do is we can get rid of my dummy code that was just there for getting the test to pass. Let's just also check that I have the puzzle input, which should be, I think I copied that into here. Let's just check that it is there. Yeah, so that's fine. I've already done that. So we have our puzzle input. We're good to go. So I'm not going to read all of this. If you watch some of the people on YouTube that do this as a sort of a, really serious about doing this as a time challenge, they do these puzzles in a matter of seconds. And they just scan and look for the salient bits of information. But yeah, I'm not that quick, so I need to read it in a bit more detail. But I think we can pick up from here. So I'm airdropped near Easter Bunny headquarters. Very exciting. In a city somewhere, and the instructions on the Easter Bunny recruiting document, the elves intercepted, start here. The document indicates that you should start at given coordinates where you just landed, coordinates, and face north, and either turn left or right by 90 degrees. Right, so this is the cardinal points of the compass, isn't it? We're gonna start at 0, 0, and if we get a left, we'll be heading west. Now, for me, I don't know about you, but it's never eat shredded wheat. North, east, southwest, never eat shredded wheat. I don't know how it's, just sticks in my brain that way. So these cardinal points of the compass. So we're going to receive the instruction, which is like right. So this would be, we're facing north to begin with. So we're turning east, and then we're traveling 2 blocks. So we move 2 blocks, and then we turn left, which means we're back facing north, and we travel 3 blocks, and then next instruction, next instruction, next instruction. So that's all fine. So it sounds like we need something that keeps track of the direction we're moving in and the distance we've traveled in each direction. Let's have a look at this. So taxi cab geometry. Oh, okay, yeah. So Manhattan. I wonder if Manhattan is maps particularly set out like Manhattan. Okay, yeah, I guess this is what we're... Yeah, okay, that makes a lot of sense. So we're just moving around Manhattan. Okay. So how do we work out the distance? So it's this green line, I guess. Is that right? And that you can only walk on the street grid. So how far is the shortest path to the destination? So so the green line is what I would call as the crow flies, but we have to measure back this blue line, I guess. This looks interesting. So in a two-dimensional real coordinate space, the taxi cab distance between 2 points. Here we go. So x1 and y1 or b are 0, 0, our starting position, and x2, y2 will be our finished location. So all we need to do then is take our finish x position, take it away from 0, and then add that to y2 taken away from 0, and then we need the absolute value of that. Okay, that makes sense. So, okay, I think we're ready. I think we know what we need to do. So I'm thinking I need something to track my position, as I said, and an X and Y. So I think what I'll do is I'll create a struct, and I'm gonna put myself on the grid. So I'm gonna call it me, and we're gonna have X, which is an I32, and then Y, which is an I32 also. And then direction will be north, south, east, west. So I think I'm gonna create an enum for that. So direction, no, not like that. I'm not. So direction is going to be a direction. And then we'll create the enum direction, and that is going to be north, east, south, and west. Oops, sort that out. All right, so I have me and I have a direction. So if we go down to part 1, we're not using the input just yet. Mismatch types. Oh yeah. So what we can do then is we can say let me equals me, and we'll start at 0, and we'll start at 0, and direction will be direction north. Okay, and then we will... So what we can do is we'll return the absolute. We want a semicolon after that, and in here we'll say 0. What was it? What was the yeah. So 0 minus me dot x plus 0 minus me dot y. Okay, so I think that's a good start. And then we will need to, and this will need to be mutable. Yeah, maybe. So we're going to need to iterate over well, we're going to need to split the input by I guess comma space, and then split it at position 1. So we split the L and the R from the number. So let's do that. So here, I'm not worried about I'm not worried about allocating this to anything, so, or assigning it to anything. So I'm just going to mark it as unused by using the underscore. And then we'll say input split. Or would I be better doing the trim here? That's okay. I think we'll do it here. I think we'll leave it where it is. I mean, so we're going to say split, and that's going to be question mark space, and then we're going to map over that and select. So map map is, well, we need a closure, so call it instruction, and then so at this point we'll have a, what will we have? Instruction will be, I guess, a tuple. No, it won't. We will need to split it at. So what we need to do is implement on me a move function, and then we'll say instruction split at 1. So this will split. So the first here, so this will split the input into our separate instructions, and then this will split our instruction into 2 parts: the instruction on which direction to turn, right or left, and then the second part will be the number of blocks to move. So I think that's going to be okay. So let's head up and sort of sketch that out roughly. Head up, not down. So let's sketch that out roughly. So we'll implement me, and we'll have function move, which takes self, which is a mutable me, and then we'll have instruction, which is a tuple of, well, there'll be strings. So let's do that. I think move is move a keyword? Yeah, okay. So the way we get around this is we use the raw blah thing. Can't remember what that's called. Oh yeah, and then me needs to be mutable. So let's go up and oh, messed up that. Let's go back, and then let, what else have we got? Type in an, okay, yeah, so we need to specify that this is a vec of used, and then expected 0 arguments found 1. What have I done wrong there? I can't go to that. Oh, did I not put that in before, or did I undo it or something silly? Okay, so that's happier. And now we can bomb up there. So instruction isn't used at the moment. So yeah, we're getting that. So here we're going to be getting like instruction.0, we're getting R or L. And then at instruction.1, we'll be getting the number. So 2, 3, 5 or whatever. So the first thing we want to do, I think, is turn. So what we could do is self.direction equals match instruction dot 0, and then this will be either L, and then we will match self.direction, and if we are facing north, then if we're going left, we want to be going west. Something like that, I think. And then we'll sort the other arms out. So if we're going east and we turn left, we'll be going south. If I get this right, this is going to be amazing. And if we're going south and we turn left, we'll be going east. East, and then if we are going, what is left? West, we'll be going, it's got to be north, only one left. So that's all fine. And then we copy that, yank it, go down here, and then if we have R, these are going to be different. So if we're heading north and we turn right, we'll be heading east. Makes sense. And then east, if we turn right, we'll be heading south. And then if we're turning south, we'll be heading west. And then if we're heading west and we turn left, we'll be heading back to north. And then we will need a default, because we need to, we don't know that everything we're going to get is going to be an L or an R, so we're going to need that. So I think that's okay. Actually, what would be nice is if enum was a doubly linked list. Maybe that's an exercise for another day. But yeah, okay, so that is sorted out our turn. So we've either turned left or right at this point, and now we need to move. So I think what we need to do is change distance or pass it into a I32. So instruction.1 no. Oh, I'm having it's a dot, isn't it? Am I right? Yeah, 1 dot parse. And then this will be I32. Oh no, we need a couple of semicolons there, and then we'll need to unwrap that. Wow, made hard work of that, didn't I? And then we will match, actually I don't want a space there, we'll match self dot direction. So we're kind of matching. Again, it'd be nice to do this all in one if we could, rather than, anyway, let's just get the puzzle solved. I don't know how long this, yeah, this is going to be a long one, sorry. So self.direction, and what are we matching on? So we're matching on direction north. We want to do self.x. No, north is on the y-axis, so it will be plus, so we're going up, plus distance, and then we'll sort out east. So east will be on the x-axis, and again we're moving in a positive direction, so that's fine. And then these will be negatives, and again this will be x. We can go back and change that to south and that to west. Distance is not happy. Why aren't you happy? Expected token. I need a semicolon there to sort that out. All right, everything looks happy. So maybe at this point we can run our tests. What do you reckon? I don't know what. I'm nervous. Oh dear. So yeah, I knew it would be too good to be true to get it in one hit. So what have we got? Let's just check that I did. So I've got, just checking the input. So R2 leaves you 5 blocks away, so that's right. To R2, 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 and 12, 12, 12 is that all looks, that looks okay. Just see, did I get any failures? Standard out, tests 5 panicked at day 167. Yeah, well, that's understandable. So what have I done wrong? So we're starting by pointing north. Instructions split at 1. Seems right. And then move self.direction equals that. So we're turning left, so left would be west. Oh, this is wrong. This is wrong. So if we are facing east, if we're facing north and we turn left, north, left, this is why you shouldn't record videos later. So north, turn left, you'll be heading west. East will be back to north. And west, yeah, that's it, isn't it? And then direction north, east, east, south, south, west, west, north. Oh, that's it. I'll be very happy. Oh, wow. Okay, well, that still doesn't mean we have solved the puzzle, but we can try, can't we? So let's run and see what it makes of the puzzle input. 253, what do we think? Are we going to have any bets? There, we put it in. I think we have to. I think if this works, I'm going to finish the video right there and we'll have a go at part 2 in another video because this has been a long one. If you've made it this far, thank you so much. Let's have a look. If I get a gold star, I'll be super happy. Submit. Yes! Bye!